Okay, so someone confirm my screen is visible and I am clearly audible. Hello, Ayan, am I audible?
Yes, sir.
Okay, okay. So now I'm starting, right? And in between the other people's join, then it's okay. Otherwise, might be they are going to see on the YouTube when I upload the files. Okay, so I'm starting. First of all, I will give a quick revision of the last class and then move forward so that it will be helpful that in the meanwhile other people join, then it's okay. Right. Okay, so let me start. So the basic instruction is same. First of all, my name is Sumit Kumar. I am the PhD research scholar at IIT Dhanbad. I am taking this class of soil mechanics, in which we are reading the basic concepts related to geotechnical engineering, and it would be helpful for all of you for your coursework or maybe strengthening your concepts in the field of geotechnical engineering. In addition to that, if you are going to give some of the competitive exams like GATE or engineering services, that is also very much critical concerning this subject, because almost more than 15 questions in the GATE examinations came from this topic only, and the average is almost 18 out of 100, so that is a huge percentage. One of the prominent
Mm.
subjects in that
वो
regard is,
उसका ब्लूटूथ कनेक्ट है सो
sorry, sorry, come again, can you repeat? Rian, are you saying something?
नो सर.
Okay, okay. So if any doubt in between, like maybe my audio is not audible, or maybe due to some internet problem, if my connection disconnected, I will rejoin. So be patient in the meeting, because this class will run for 2 hours. I try to finish it by 5, but sometimes, as the previous class, it takes almost 15 minutes more time. So uh, that will be more helpful, because in the last I keep the small problems so that it will be helpful. In the last class, I want to discuss that. I want to give those questions, and the answers should be come from your sides. But due to time constant, I go very quickly. And in today class also, we have some of the very good problems that will take some time. So in today class also, maybe at the end of the class, whatever time we have, and let me see that what is the possible, maybe some theoretical concepts I will go very quickly, so that we can cover the numerical problems or the other problems which are associated with the subject. So first of all, what I am telling, that this subject is very crucial and it will be helpful for all of you in the various examination, various competitive examination. If you are already graduated student or maybe the final year students, it will be helpful in one way or the other, uh, so that it will shape your career in one way or the other. And if you are the professionals, so it will strengthen your knowledge in the field. Right. So I think so. The last week class has been done. So some assignment problem is also given to you from the NPTEL team, and I hope that there will be no problem in solving those problems. Okay. And so we could also discuss some problem other than that. I think so. In the last class, very theoretical questions are there, and which more or less get solved from those slides only, which I have shared with you, because up to that class there is no numerical concepts or the problems associated with the real field problem, like the void ratio, soil density, or maybe the permeability. Those things are not there. From this class, some numerical concepts are came into picture. So if some problems are there in any class regarding those, also we could discuss. There is a instruction that I can't discuss the assignment problems over here, because that is the curriculum that you will awarded some mark for that. So but if some confusion regarding that, I could solve one or two problems from there also, but that problem need to be solved from your side only. But once the solution has been published and if still there will be doubt, I will try to cover them. Okay. So I'm saying that I will quickly go through the slide which we have covered in the previous class in the 5 to 7 minutes, and then move to the new content so that it will be a quick revision. Okay. So I'm starting with the previous class content and I will cover those in 5 minutes only. Okay. So in the previous class, we have primarily focused on the origin of soil index property and the classifications. So in that, we have understood that what are the agricultural and engineering soil, the all the structures, all the structures, maybe the building, roads, railway, bridges, everything is constructed on the soils. Basically, soil is the building block also because the brick which are used in the construction process, it also contain the soil one. So it is a building block. It has been used all across the construction practices. Here are the soil horizons we have discussed. We also discussed about the soil characteristics. We have understood that the how the formation of soil takes place, the how the geologist has classified the earth crust as rock, whether hard or the soft deposit. Afterwards, we have understood the rock cycle in which we have read the igneous, residual, and metamorphous rock, sedimentary rock. So those things we have discussed in the detail in the previous classes. And so I think so those contents is with you, and the assignment problem came in this class. From there only the examples of the igneous rock is granite, gabbro, and ballast, their characteristics, how the rock get formed, the stratified, what it means by strata is discussed over here. In the figure, I have given one example about the strata, that the different characteristics in the different layer of soil, right? The example of sedimentary rocks, metamorphous rocks like slate, quartz, and marble has been elaborated in the subsequent class, in the earlier classes. Afterwards, the formation of soil through various techniques like the transported soil, residual soil, organic soil. The strength of those soil is also discussed in the previous class, right? And how when the water carry, like the river carry the big rock material with themselves, the heavier part of the soil get deposited at the upstream side while the lighter part carry forward, and that's why the gravels are found in the upstream section. That is also elaborated over here. The picture has been also shown that as the flow takes place, the heavier particle like sand and gravel get deposited first of all, after subsequently the silt and the clay got found. Their shapes, specifically when we talk about the transported by air, we have said that the spherical and very smooth space are found to be there. Then the residual soil, the deposit which reside on the parent rocks only, and the formation takes place over there is the residual soil. Then the discussion on the laterites are found by the chemical weathering process is also elaborated. At the end, the organic soil like pit, organic soil, the formation of organic soil through the decomposition of the organic matter like the animal, plants, vegetative matters has been covered. And subsequently the different organic soil component like peat, fibrous, pseudoplastic, amorphous, that has been elaborated. Subsequently the characteristics we have discussed like the cohesion and the angle of internal friction are the two shear strength parameter on which the characteristics are of the soil is governed, that has been elaborated. Then the different in the property of the soil with the other structural property like the steel and concrete has been formed like the steel, and in steel and concrete we have manufactured it, so we have a control over that, but in the soil it is formed through the natural process, so the control is not in our hand, it is by the nature only. Then the permeability, compressibility, and the shear strength are the some of the soil characterization which we haven't elaborated in the previous class, From today, some of the property of the permeability we are going to discuss, and the compressibility and the shear strength are going to discuss in the subsequent classes. In the field, how we identify the soil, whether it is a sand, silt, or clay, that is elaborated in the tabular form. And the sieve analysis, one of the important factor for the soil classification, has been covered in the previous classes. Subsequently, we have seen this graph, which is show the grain size distribution, from which we have found the coefficient of uniformity and coefficient of curvature. And then the various Atterberg limit, like the liquid limit, plastic limit, shrinkage limit, we have covered. At the end, we have seen this graph in which we have learned that the soil, first of all, replace the air void from the water void till the shrinkage limit. Once the shrinkage limit get reached, the water is the soil is in the fully saturated condition. Afterwards, when the water get added, its volume get increases. In addition to that, we have also understood that up to the shrinkage limit, it is in the solid form. Subsequently, when the water contents get increased, it converted into semi-solid. And between the plastic limit and the liquid limit, it is in the plastic solid form. Afterwards, after the liquid limit, if water remain get added, it converted into the viscous liquid one. Okay, so up to this we have discussed. Afterwards, some of the problems regarding the same has been covered in the previous class. So now I think so we can move with the new content, and we cover the new discussions which are pointed out for the today. Okay, so let me start with the today class with the new content. Like first of all, we are going to read the three-phase system, the three-phase diagram. So understand the basic consideration. If we talk about the soil, soil looks in the form of solid form only. If we ask a layman, layman is a person who have the no knowledge and or no technical knowledge, basically no knowledge. Everyone has some knowledge, maybe they have more knowledge than us, but when we talk about no knowledge, we talk about the technical knowledge. They are not the technical persons who understood the technical terms. Might be if you go at some places, the various people who are working in the field, like the laborers or maybe Rajmistri, they might have sometimes more knowledge than the professional engineers who have worked for many years. But when we talk in the technical term, they are unable to answer. So we are the technical peoples. When we talk about the three-phase diagram, if we ask any person who have known the technical concern, we say that we stand on this soil. What is the characteristics of this? Whether it is a solid, liquid, solid or liquid. Everyone say it is a solid only, but it's not like it is only solid itself. It must have some water in it. So some water content is there. So it has the content of solid and liquid as well. Afterwards, it might have some pores in which the air is penetrated. Some air void could also be there. So it may be in the three-phase form, like the solid, liquid, and air. So that's only we are going to discuss from, from here. So first of all, we start with basic, then elaborate it with the soil characteristics as well, right? So over here you see, as I have said earlier, in the actual form, soil look like this. So what is this? This is the soil. When we see this here, you can, okay, let me open the ledger so that I can show you. Over here, you see that over here, these are the soil particle in which the large size particles is also there, fine size particle is also there, and this is the mixture of the large, fine to coarse size particles. So there must be some void in between, and if the void is there, in void there might be water, there might be some air trapped inside it. So it is not only solid; it must be some other form of voids is also in there, and the voids might be filled with either of water or air. So this is the actual form, but when we idealize it, we make it form in the two section, like the volume of solid. over here, and the volume of void is upside. In the volume of void, it might be air, it might be water. So we will see as we move forward for the three-phase system. We see we define the three-phase system in the three form in which the solid, liquid, water, that is, and air are there. Okay, so let's see this picture. Okay, so okay, over here the term come, that is the void. So if the void comes, then what is the void? Void is the empty space. Void is the empty space in the soil volume that might be filled with the water or air. So this is also defined. A term is also explained for this, that is named as the void ratio. Void ratio is nothing but the volume of void to the volume of solid, and its range lie in the form of 0 to infinity. Now there is a question that how? Okay, now you see, let me draw one picture. Okay, now you see over here, there is this phase system in which over here solid and over here void, right? So there might be condition that there may be no voids, only solid is there. If we consider this cross section only, then it is a solid only. Then if we say that the void ratio in this volume, so there is no void over here, volume of void we have kept upside, right? So there might be a condition in which the no void is present. It is practically not possible, but theoretically there may be chances that there is no void. So the void ratio is the volume of void by volume of solid. So there is no volume of void, hence the void ratio may be 0. Okay. Subsequently, if some voids is present, then the void ratio, okay, there is a volume of void by volume of solid. Okay. Afterwards, when the some volume of void is there, then it's become greater than 0. Okay. So its value lie in that way from 0 to infinity. Now talk about the porosity. Porosity is the volume of void by total volume. Okay, over here, this is the total volume. This is the total volume. While this is the volume of void, then the volume of void by total volume is the porosity. And volume of void can also be, total volume can also be written as, total volume can be written as the sum of the volume of void plus volume of solid. So that's written over here as volume of void plus volume of solid. So now how you can write it? Now you can write it as, okay, volume of void 1. Okay, so let me rewrite it again. There might be some confusion. The volume of it can be written as 1 upon 1 plus volume of solid by volume of void. I think so. There will be no confusion. How that we have divided by volume of void from up numerator as well as denominator. When we divided the numerator by volume of void, it becomes 1. When we divided volume of void by denominator, volume of void by volume of void becomes 1, and volume of solid by volume of void. Now we know that volume of void by volume of solid is nothing but the void ratio E. So this can be rewritten as 1 upon 1 plus 1 by E. Right. Now when we solve it, it become E upon 1 plus E. So in this manner, the porosity is E by 1 plus E. Similarly, afterwards, when we write some relation for void ratio, it by become n by 1 minus n. Similarly, in that fashion only, from this phase diagram only we can find those concerns only itself, right? Now, we move further in the three-phase diagram. So, the specific gravity of material is now we talk about the specific gravity, because specific gravity is also one of the most important characteristics of the soil. So, that is the specific gravity of a material is the ratio of weight of the mass of weight or mass of the volume of a material to its weight or mass of the equivalent volume of water. Basically, over here it is written water, but in general we can say that it is the ratio with respect to standard fluid, and the standard fluid could be varied from place to place, but in general for the soil it is considered water only. In the soil mechanics, the most important specific gravity is that of the actual soil grains and is given as GS. That is the specific gravity. So from the definition, it has been seen that the soil sample with the volume of solids and weight of the solids is WS. So GS is defined as WS upon Vs into gamma W, because Ws is the weight of solid. Ws is the weight of solid, while Vs is volume of solid. When we multiply volume of solid by density of water, it becomes weight of water. So weight of solid by weight of water. Weight of water is the standard fluid in this case. So it becomes Gs, that is the specific gravity. And this value is 1 gram per cc, that is the density of water is 1 gram per cc, 1 gram per cc. Okay. And when we talk about gamma W, that is the weight specific weight density. Density of water density of water is represented by G, or the weight density is represented by rho G, where G is the acceleration due to gravity. We have also seen in the last class also, so that the specific gravity of normal most of the soil lie in the range of 2.6 to 2.75 only, but for the organic soils its value sometimes found to be less as well. So we can see in that regard itself as we move forward, right? Now now moving forward, we can see that over here the three-phase diagram is presented as we have discussed earlier, and that in the three-phase diagram there must be solid, there must be water, and there must be air. So the three conditions gets generated. First of all, the dry soil. When we say dry soil, whenever the term comes dry, there must be the absence of water over there. It is said that there is no water present over there. That's why it is dry. Otherwise, it's never be dry, right? So in the first picture, you can see the dry soil is represented. If it is a dry soil, so there is only two phase, that is the solid and air. The void which are present over there is filled with air only. There is no water component over there. Hence, it is a two-phase system in which the solids and air is presented, and their volume and is represented over there. Now move to the saturated soil. So saturated condition, we have understood that at the shrinkage limit, the all of the void filled with water only, so it becomes the saturated. So hence here there is no air content is there, so it is a saturated soil. There is only two components is present, that is the solid and water, as shown in the figure B. Okay, now move further. When we move further, we see the partially saturated soil. So what is this partially saturated soil? So the partially saturated soil is that soil in which the three phases are present, in which the solid, water, and air are both are present in the void. How? That the sum of the voids is filled with air while the others are filled with water. Okay, give me a minute. Okay, so over here, the in the partially saturated condition, the three phase has been represented. I think so. Up to this, there will be no confusion. Now we talk about the degree of saturation. So degree of saturation again defined on the void ratio, volume of void one. Now you see in the previous three phase diagram only, the sum of the void is filled with water, while the sum of the void is filled with air. In the picture C, in the figure C, you can see that the sum of the air, water is there, the sum of the air is there. This is the ideal condition in which the three phase diagram has been plotted. So the volume of some of the volume of void is filled with water, and some of the volume of void is filled with air. When we talk about the degree of saturation, we see that the volume of water by volume of void. So volume of water by volume of void is the degree of saturation. So again come over here in this figure. Now you see that in the figure B, all the voids is filled with water only. So the volume of water by volume of void is equal to 1. Am I clear? So in that condition, the degree of saturation is 1. But at the same point, when the degree of saturation is asked for, the diagram presented in the figure A, over here, the volume of water is 0, volume of void is V, volume of void is VV, and in that case, condition, the degree of saturation is 0. So over here also you can see that its range lie in the range of 0 to 100%, which is also explained with the previous figure ABC. Over there, the three phase diagram has been represented. Now, the degree of saturation is 0 for the completely dry soil, as shown in the figure A, while the degree of saturation is 100% for the completely saturated soil, which condition is represented in the figure B of this slide. Right. Now, am I missing? Okay. Yes. Okay. Okay, so I think so up to this there will be no confusion in anyone's mind. So we will move ahead. Now we move to the density. We already read weld density, that is rho into gamma W. Over here, density defined, density is nothing but mass per unit volume. Now let me explain this. This thing is already known to you. No need explanation, but just for sake of convenience, I will explain this. That this is a solid which has the might be mass of m, and it has its volume equal to v. If there is any solid, anything is present, it must have some mass and it must have some volume, because whether it is solid, liquid, anything, it must have some mass and must have occupy some volume. So when its mass divided by their volume is known as weight density, and the unit of mass is nothing but kg, gram, whatever you say, while the unit of volume is meter cube, liter, centimeter cube. So its unit become kg per meter cube, or maybe gram per centimeter cube, whatever feasible, whatever CGS unit, MKS unit, SI unit you want to assume. Right. Now we come to the unit weight. Unit weight is nothing but mass density. Sorry, weight density. So over here, unit weight is weight per unit volume, and weight is nothing but um, weight is nothing but basically weight is equal to mass into gravity. So gamma is nothing but rho into g, where g is the acceleration due to gravity. Okay. So in that manner we defined. So the density of water is nothing but 100 kg per meter cube, while the weight of 1000 kg of water is 1000 into 9.81 Newton, that is the 9.81 kilonewton per meter cube is the unit weight of water when we talk in the term of kilonewton per meter cube. Now we move to the next term that we have understood the unit weight. Now we understood the bulk unit weight. So the bulk unit weight is nothing but the weight in the given condition divided upon the volume in the given condition, that is nothing but W by V. If we talk in the term of the phase diagram, so Ws is the weight of solid. Sorry. Okay, so Ws is the weight of solid, Ww is the weight of water. When it is divided by the volume of solid plus volume of void, because again, move to the three-phase diagram for a minute. Over here, you see that solid is there, water is there, and air is there. So solid have some weight, water have some weight, but air has negligible weight. So we assume weight of air as 0, but it have some weight, it have some weight. So the total weight is weight of solid plus weight of water. But there is a volume for solid. It's occupy some volume. This also occupies some volume. It has been viable. But in addition to that, air also occupies some volume. Now I give you example that how air occupy your volume. You take a bottle. Hmm. Any bottle, any water bottle. If there is no water in, no air inside, no, it shrink. So that condition could not be achieved in the normal condition. But when water bottle is kept anywhere, there must be some air inside. So in that way only the soil also intercept air in the its void, but the volume of void is the sum of volume of water plus volume of air. Hence, over here when we define the bulk unit weight, the total weight is weight of solid plus weight of water and divided upon the volume of solid plus volume of void. Volume of void is the combination of volume of air plus volume of water. Now you again see that we have rewrite these equations in the form of gamma bulk equal to G plus SE by 1 plus E into gamma W, which is nothing but a small type of derivations which has been done from the same concepts itself. So this relation sustain for the all type of soil. Now if it's become the saturated, if it is saturated, then SR become 1, and the equation for the gamma saturated get converted into Gs plus Se by 1 plus E2 G plus E into gamma W upon 1 plus E. Hence the saturated weight by total volume is nothing but the saturated unit weight. And it is, as I have said earlier, that when the soil is saturated, SR is equal to 1. Now see, now we talk about the dry unit weight, that is the gamma D. So the gamma D is the dry unit by dry volume, and the dry weight by dry volume. In the same condition, you see in the dry condition, this SR value, this over here the degree of saturation is written, this SR value become 0, because in the dry condition we have already seen in the three-phase system that in the dry condition the volume of water is 0 and degree of saturation is volume of water by volume of void. So if the volume of water is 0, then the SR equal to 0. If SR equal to 0, then gamma D becomes GS into gamma W upon 1 plus E, as shown over here. Right. Now the other condition is also given that the buoyancy buoyant weight unit weight equal to saturated unit weight minus the unit weight of water. Over here, the submerged unit weight we are talking about. Buoyant unit weight is nothing but the submerged unit weight, that is gamma bulk minus gamma W. Sorry, gamma set minus gamma W. So gamma set is nothing but G plus E into gamma W minus gamma W. That becomes G minus 1 upon 1 plus E, that is the submerged unit weight. Now, when we move ahead, we see the relation between the W, that is the gamma D and gamma 1. Sorry. So over here, the gamma bulk is nothing but weight of water plus weight of solid divided by volume. While in gamma dry condition, there is only weight of solid because there is no water. So weight of solid divided by total volume. So W equal to WW upon WS, that is the weight, water content is equal to weight of water by weight of solid, or nothing but weight of water equal to water content into Ws. Now, when we talk about the gamma bulk, so it become Ws by V into 1 plus W, and gamma D become gamma W by 1 plus W in the same manner. Okay. Okay. Now we see the relation between the W, GS and SR. So we already know that the water content is weight of water by weight of solid. Weight of water is nothing but volume of water into gamma into W, and weight of solid is nothing but the volume of solid into gamma W into GS. And when the volume get neglected from upside and downside, it become the gamma W get neglected, it become volume of water by volume of solid into G, and we already know that the void ratio is volume of solid by, so volume of volume void by volume of solid. So over here it get converted into SR into E upon GS. So this formula is SR into E equal to WG. This is nothing but a simple trick to remember this. And this is a Savag formula where SE equal to WG. For saturated soil, SR equal to 1, so E equal to WG. Right. Now, up to that we have read the degree of saturation, but there is also a term that is Na. There is another term AC, where AC is the AC is the air content, that is the volume of air by volume of volume of air by volume of void, as the degree of saturation, volume of water by volume of void. So AC plus S is equal to 1. Similarly, over here, the air content term is came, that is the volume of air by total volume. And this become volume equal to volume of solid plus volume of water plus volume of air. When we solve it in the same fashion, we finally come to know that the gamma D is also given as 1 minus Na into Gs into gamma W by 1 plus Wg. Okay. So there is a in for this up to here. Now we move further in the three-phase diagram with some of the numerical problems. So before moving over there, okay, let's move to these problems. Afterwards, at the end of the numerical problems, we are going to take a small 5-minute break so that the mind get recovered, and then we move further. So first of all, see this question, and I will explain this question in step by step. But first of all of you read by yourself, so that what do you understand from this question? Let me see. Okay, now I read that a moist soil sample weight 346 gram. After drying at 105 degrees Celsius, its weights get 284 gram. Specific gravity of the mass and the soil solid is 1.86 and 2.7 respectively. Determine the water content, void ratio, and the degree of saturation. So first problem is very simple. First problem um, I will explain all the problems, but the uh, similar problem like this, I will suggest you to take any of the soil mechanics book. Hmm. Any basic soil mechanics book, and try to solve some problem from these basic topics. If you solve as many as problem, your concepts become stronger and stronger. So over here, it is seen that its weight get reduced while hitting at 105 degrees Celsius. So at 105 degrees Celsius, it's come into the dry state. So first of all, the weight of water is nothing but 346 minus 284 gram, whatever it comes. I think so 16 and 46 50 62 gram, I think so, maybe. And so the weight of water by weight of solid is nothing but 284 gram. By this you are able to get the water content. Subsequently, the void ratio and the degree of saturation also need to be calculated. So let's go step by step with the water content. Let me show the solution also I have did for you. So over here you see that the water content is weight of water by weight of solid into 100. So weight of water is equal to uh, moist weight minus dry weight, that is nothing but 346 minus 24, as I have said 62, it is 62 only. Weight of solid is the weight of the dry soil solid, that is the 284 gram. Yes, the water content is nothing but 62 upon 284 into 100, that is the 21.83%. So you can write it as 20 at the one decimal place, maybe 21.8, whatever you do. Okay, now see the second part of the problem is say the void ratio, and third part of the problem is say the degree of saturation. Okay, so to calculate the void ratio, see from the left hand side only, it is given that the bulk specific gravity as 1.86, while the specific gravity GS is 2.70, mass specific gravity. No, not mass, true specific gravity. So the bulk specific gravity could be written as mass of a moist soil by volume into rho W, but it is more commonly written as Gm equal to W moist by V total into rho W, as Gs equal to Ws by Vs into rho W. How that you know that it is written that more commonly the relationship for the moist and the dry soil is used to find the void ratio only. So Gm equal to W moist by V total into rho W. Now Gs become the Ws by Vs into rho W. The void ratio using in the mass and specific gravity E is equal to SE equal to WG होता है. तो SE equal to WG over here this equation has been written. Some mistake is there, I think so. So finally, when we calculate from this side to that side, we are able to find as the void ratio as 0.77. We can solve in the simpler manner also. It is a very complex solution, which I look that this is not required. And subsequently, when the void ratio is found as 0.77, the degree of saturation you can calculate it easily. That is nothing but Se equal to Wg. We already know the S value. Sorry, we need to calculate the S value. We already know the E, that is the void ratio, and we know the Gs, that is 2.7. Hence the degree of saturation is come out to be 76%. And the summary of the answer is also printed over here, that I don't think anyone needs. Now move to the second problem associated with this topic only. So the second problem say that a soil deposit is being considered to fill or building a site in its original state in the borrow pit and the void ratio is 0.95. Based on the laboratory test, the desired void ratio in its compacted state at the building site is to be not greater than 0.65. Hence, the question said determine the percentage decrease of the volume of the deposit from its original state. So, two important equations you need to. What are those two equations? So, one thing is that the volume of solid and weight of solid remain constant. If you take any soil and its solid content and weight of solid content, it never going to change. This is the most important things you need to understand. Constant. Okay. Now, and there another relation is also there. What is that relation? That relation say Vs, that is the volume of solid, equal to Vt. This is equal to, okay. Vs equal to Vt and Ws equal to, which is written over above, Ws equal to Wt by 1 plus. Okay, so these two equations are very much important. Understanding that the volume of solid and weight of solid are constant. So in that case, you are able to solve these problems. Now read the question again. The question say that a soil deposit is being considered as a fill for a building site in its original state in the borrow pit. The void ratio is 0.95. Basically, the soil has been taken from here. Based on the laboratory test, the desired void ratio at the compacted state at the building site is to be not greater than 0.65. To determine the percentage decrease in the void ratio of the deposit from its original state. Over here you can see that the original void ratio even is 0.95, the compacted void ratio is 0.65, and E is nothing but volume of void by volume of solid. So that thing you need, you already know. Just you see V equal to Vs plus Vb equal to Vs into 1 plus E, and the initial force V1 equal to Vs, the initial force, initial total volume is V1 equal to Vs into 1 plus E1. As I have already said, Vs equal to Vt by 1 plus W. Here V1 is the total volume, so 1 plus E. So V1 equal to Vs into 1 plus E, while the V2 equal to Vs into 1 plus E2. Subsequently, when we calculate the percentage decrease as V1 minus V2 by V1 into 100, you find that the E1 minus E2 by 1 plus E1 into 100, and this percentage come to be 15.38%, and hence our problem gets eradicated, solved. Now you see we have another problem on the same borrow pit question. So over here I am going to give you a 5-minute break. This screen is visible only for that meantime. So if you can able to solve this question in this meantime, then it's okay. Otherwise we will discuss at the start again when we resume our session after 5 minutes. So till then, try to solve this problem. Okay, welcome back everyone. So let me resume the session from here only. I think so. Those who have tried that problem must be solved, but if not able to solve, I will discuss this. But the similar problem which we are going across over here is going to be discussed, going to be asked in your exam as well, which are going at the end of the 13th class sessions. In that, also these type of problems you have interacted, and in addition to that, you are going in the to look out at the quiz questions which are there, and that's also have a similar types of problems. Okay, so let me resume from here one. So I will read the question again and then move to the solution. So the question say that, okay, let me see, my audio is on. Okay, so audio is clear. Audio and presentation is visible to everyone.
Yes, sir.
Okay, okay, thank you. Okay, so the question is there that a soil sample taken from the borrow pit has an void ratio of 1.15. The soil is to be used for the compaction project where the total of 100,000 meter cube is needed in the compaction state with the void ratio uh, pre- predetermined to be 0.73. Hence, the target void ratio is this. The determine the how much volume to be excavated from the borrow pit. So it is a very simple problem. Again, what equations, what relations we are going to use? We are going to use this relation only, which we have written in the previous slide. That is Vs equal to Vt by 1 plus E. Okay, this relation. This relation we are going to use, that is Vs equal to Vt by 1 plus E. Now, where Vs is the volume of solid, Vt is the total volume, and E is the void ratio. The void ratio is given to us. Now let's read the question. Here the soil sample is taken from the borrow pit has the in situ void ratio. So the void ratio of the soil in the void borrow pit has the void ratio of 1.15. The soil is to be used for the compaction project where the total volume is 100,000 meter cube, and uh, over there the void ratio is 0.73. So how is going to solve? We first of all write the 100,000 equal to the solid soil is to be used for a compaction project where the total of itna meter cube is needed to be in a compacted state with the void ratio predetermined to be 0.73. So 100,000 equal to divided by 1.73 equal to Vs, and that Vs is equal to Vt upon 1 by 1 plus 1.15. So I have said, but might be you are not understood, but let's see the solutions. In a similar fashion only they have solved. So over here again given term is E naught equal to 1.15, E1 equal to 0.73. The volume needed at the compaction side is 100,000 meter cube. The volume to be excavated from the borrow pit is taken as V naught. Now, the total volume V is related to the Vs, as I already said, Vs remain constant. So the V equal to Vs by 1 plus E. Over here, V naught equal to Vs into 1 plus E, where V naught is the unknown, and V1 equal to Vs by 1 plus E1, where E1 is known to us, that is 0.73. So from in the last two equation, if we write E1 value as 0.73, V1 value as 100,000, we are able to find the Vs. When we able to find the Vs, we keep it in the above equation, and E naught is already known as 1.15, so we are able to find the volume V naught. Okay, so that's thing only we have done. First of all, we have calculated Vs equal to V1 by 1 plus E1, and in that regards, we are able to find the V naught, and hence the unknown volume which is required over there. There might be some calculation mistake over there, I'm not sure, but the concept more or less I think so everyone get understood. Okay, let me move to the next question. Okay, there are the many problems related to the same. I think so. I will share the PPT with you, and you could solve by yourself, or might be I come to end at the end. I will solve because I have to cover many more things. Okay, let me discuss one more problem. Then I will leave the two problem for you. Okay, let me discuss one more problem. Over here, again the similar concept. The question is there. Over here, the soil sample in its natural state has when fully saturated water content 32.5%. Determine the void ratio, dry and total unit weight. Calculates the total weight of water required to saturate the soil. Mass of volume 10 meter cube. So it is a simple problem. The solution I have already done over here. I will share it with you. You easily understood because I don't think so. This basic thing I need to discuss in so much detail. If required, I will discuss in some other class because in today we have only 1 hour left and many more things to cover. So I will skip this. I will share the PDF. Now, again, this question is also based on the borrow pit problem only, in which the total cost is also given, and we have to find the most economical section. Over here, also you use the same equation as a volume of solid equal to total volume divided by 1 plus void ratio, and the void ratio of 0.7 is given. Uh, for the soil, and the void ratio of borrow pit as 0.8, 1.7 and 1.2 is given. So you calculate the volume, multiply the volume with the cost as 200, 180 and 160 subsequently for the borrow site 1, 2, 3, and you are able to calculate the cost. So this is the homework that the question number 5 and 6 you need to solve by from yourself. And in addition to that, the four other problems which are mentioned over above, you need to solve by your own hand with pen and paper so that you can easily grasp the concept. Because for the time being, if anyone teaches you, anyone discuss the problem and solutions, this is not the right way to get the better understanding of the subject. Hence, it is my sincere request that you must solve this problem by yourself. Okay. Now I move to the next part, that is the permeability and seepage. Up to this point, we have understood the in the previous class the origin of soil. Over here the three-phase diagram. So those things we have discussed. Now we are moving to the new topic in a way, that is the permeability and seepage. Because you know that the soil is a permeable. When we talk about the permeability, it is the ability of the soil to allow the water to flow through them. So that discussion we are going to carry forward from here. Now, first of all, starting with the when we talk about the permeability, then we talk about the movement of water through soil mass. So there must be water present in the soil, soil surface. Now, I start with a very basic term, basic concept, that in all our household we normally use the hand pumps. But earlier we have the hand pumps in our house, and nowadays there are many submersibles and others things are available, specifically across the country. At many places where the water table is not far below in the ground, we use hand pumps, or at some places we use submersibles, but that water comes from the ground surface only. So it is very much viable that the water must be present in the ground surface. So depending upon the rechargeable capacity of the ground, the water table found at the greater depth or maybe at the mild depth. So, but the water is there. But if the water is there, it is not possible that it get replenished, it get replaced um, by the water. But when the rain takes place, in general, if you have gone at any places where there is only soil, no concreting has been made, neither it is a road surface. Suppose any field in villages or maybe in town also, if any field is there over where the soil is only, when first rain takes place, you see that the water get accommodated on the ground. If the drainage facility is not there, you see the water get accommodated over there. Specifically when I talk about the first rain or the second rain, when the rainfall intensity not too much high that it get flooded out, so over there you see that the water get accommodated, but after 1 or 2 hours, without any surface drainage facility, the water gets vanished. So where does that water go? Is all those water get evaporated? No, because the process of evaporation require time as well as the sunlight in one way or the other, or the heat, so that it get evaporated, converted into the cloud, or maybe then condensed and can get the rainfall again. So that is not the case. So those where those water get vanished, so that water get vanished as those water, the water content which is present on the field is seeped into the ground. Earlier you have read the rainwater harvesting or many more things like that. Our elders also used to say that don't do the concreting all over the ground across your houses whichever be built in the city, because they know the important that when the rainfall takes place, some water move down into the ground, so the water table remain replenished and remain at in the upward direction in the very low depth, so that the problem of water doesn't grows up. So there is a water in the soil surface itself, but if that water is present, that water also get moved from one point to other point within its vicinity. How its movement takes place? Its movement takes place because soil allow them to move through them. Again, in the previous class itself, we have read about the three of the soil types. The different soil types like gravel, sand, silt, clay. So over there, we have seen that the gravel has very high permeability. In general, we have understood now. We have seen. I have given an example in which I have said that take a container, fill it with gravel, and then allow the same amount of water to flow through them. It will take a very less time to flow out, while at the same place if the silt or the clay is there, the movement of water is very much difficult, and it will take a large amount of time to flow out the same amount of water which is taken on the similar container. So in the same way, it is the permeability. For the gravel or the coarse grain soil, the permeability is high, the water flow out very easily, while for the fine grain soil, it is difficult to move out. Similarly, when you read the environmental engineering, the environmental engineering subject like environment 1, environment 2, over there also you see that these soil particles each one used only in the slow sand filters, or over there the particle size is become very much important, through which the water flows out, so that the fresh water get collected which need to be supplied in the house. So it is very much clear that the soil allowed the water to flow through them. Now come over here and talk about the subsurface water. So it is written that all water found beneath the earth's surface, the main source of surface water is rainfall, right? When the rainfall takes place, it sits into the ground and it replenishes the groundwater table, which percolates down to fill up the voids and enter sieves. Water can penetrate to a considerable depth, estimated to be as much as 12,000 meters, and that is huge. That is huge distance up to which the water can percolate down. Below this level, water cannot exist in a free state, although it is often found in a chemical combination with the rock metals. Okay, so water found up to a depth of 1200 meters below the ground surface is huge distance, right? Now, the subsurface can split into distinct zones. Yes, we talk about the saturation zone, dry zone, and many more zones, which we are going to discuss over here. So first of all, the subsurface can give me a minute, please. Okay, so I am talking about the subsurface. The subsurface can be split into two distinct zones. First is the saturated zone. This is the depth through which all the fissures, void, etc. are filled with water under the hydrostatic pressure. The upper level of this water is known as the water table, phreatic surface, or the groundwater level. And the water within this zone is called phreatic water or the groundwater. Right. Now, now the water table tends to follow in a more gentle manner the topographical features of the surface. At the ground water level, the hydrostatic pressure is zero. So, another definition of water table is the level to which water will eventually rise in an unlined borehole. Correct. The water table is not constant but rises and falls with the variation of rainfall. As I have said earlier, that specifically before the rainy season at the peak summer, it is found to be fall below a certain level. At the same time, when the rain comes, specifically when you see that when we are going to grow the crops like rice or maybe in the kharif season, sometimes you found that the water table is too much low that we need to irrigate the ground with the boreholes or maybe if the irrigation facility are there with the help of canals. So the water level get fluctuated depending upon the atmospheric pressure, temperature, etc. And the coastal regions are also affected by tides. If the tides bring water with itself, it's replenish the water at some places. When the water table reaches to the surface, the springs, lakes, swamps, and similar feature can be found. We have seen some of the springs are present at many places. This is due to the water table reaching to the surface. Okay. Especially there are many lakes are also there. Are the similar examples that the clean water lake like that it might be present in the Orissa, I think so, as I recall, might be wrong. So over here you can see the ground surface is visible and the water table is also visible at the downstream side. At that section, the water table is there, and we can bring out the water from that surface by the means of mechanic by many mechanical methods. Now, when we talk about zone, we have seen that there are various zones, the zone of saturation, zone of aeration. Okay, aeration zone is there. So this zone occurs between the water table and the surface and can be split into three sections. Over here you see that the water table is there, ground surface is there. Between this, the zone is present which is said to be the aeration zone, and this aeration zone is split into three surfaces. Now you see the permeability. In permeability and seepage we talk about the capillary fringe. So owing to the capillary the water is drawn up above the water table into the interstices of the soil or rock, the water held in this manner is in a state of suction or the negative pressure. Its height depends upon the material, and in general, the finer the voids, that greater the capillary rise. Okay, how much the fine soil particles, the capillary rise is more. Instead, the rise can be high as 2.5 meters, and in clay it reaches twice the amount as illustrated earlier later. Okay, now the talk about the intermediate belt. A rainwater percolates down to the water table. A certain amount is held in a soil by the action of surface tension, capillarity, adsorption, chemical action, etc. The water retained into in this manner is termed held water and is deep enough not to affected by the plants. Subsequently, talking about the soil bed, the zone is constantly affected by the evaporation and the plant transpiration. The moist soil in contact with the atmosphere either evaporates water or condenses water into itself until its vapor pressure equal to atmospheric pressure. The soil water in atmospheric equilibrium is called hygroscopic water. That hygroscopic water is also there. The moisture content is known as the hygroscopic water content, that is of not very much huge. Okay, so we have read earlier as well the aeration zone, saturation zone, and the rockfill zone. As it is mentioned in the aeration zone, it is divided into three sections. So the soil water is shown as a soil belt, in which the root is of the plants are also there. Then the intermediate belt is present. Subsequently, the capillary water is there, in which the water table is present due to the capillary rise of water, as it has mentioned earlier that in the very fine sand, it is in a very fine material, it is high, while for the coarse relatively coarser material it is less. Now afterwards the water table come into picture. When the water table is there, the groundwater table is there, hence it is a saturated zone in which the free waters are present. Subsequently the internal water rock flow zone came into picture. Now talking about okay, the surface tension is also a phenomena. This is a property of water that permit the surface molecule to carry a tension force. The water molecules attract each other and within a mass of water, therefore balance out at the surface. However, the molecules only attracted inwards and towards each other, which creates a surface tension. The surface tension causes the surface of the body of the water to attempt to contract into the minimum area. Help a drop of water is spherical. Okay, that's not very much important. Now, surface tension is given the symbol, okay, T, and okay, it's the value, the T varies slightly with the temperature, but the variation is small, and an average value usually taken of the surface tension of water is 0.00075 Newton to 0.075 Newton per meter. Now talk about the capillarity. As it is mentioned earlier, when we see the zone of aeration, free water zone, over there it is the capillary water is also mentioned there due to capillary rise. Sorry. The fact, talking about the capillarity, the fact that the surface tension exists can shown by the familiar laboratory experiment in which an open-ended glass capillary tube is placed in a basin of water subjected to atmospheric pressure. The rise of water within the tube is then observed. It is seen that the water weights the glass and the column of water within the tube reaches a definite height above the liquid in the basins, that is said to be the capillary rise. When we move forward, there is a question mentioned over here in which it say the classification of soils at the two clay A and B have the following property: which of the soil is more plastic, which of them is softer. Inconsistency, classify the soil as per IS classification. So you know that it is a clay when liquid limit is mentioned as 44 and 55. So um, clay A is intermediate because the liquid limit range lie between 0 to 35, 35 to 50, and more than 50 as low, intermediate, and high. So why clay A is intermediate, clay B is high, and when you calculate the IP as the liquid limit minus plastic limit 44 minus 20, it is 24. Now calculate 0.73 into WL minus 20. If you if it's come if it's come less than 24, then it is a sealed. It's greater than 24, then it's a clay. So in a similar way you can find it for clay BB. Okay, so in that manner you are able to find, you use this graph. Okay, this A line equation is 0.73 into WL minus 20, and on the basis of that you can classify, right? Similarly, the other problem associated with same is given, and this is also related to this shrinkage limit concept only, in which we have studied now, as you remember this in the start of the today class also we have discussed. This is a problem associated with the previous class only. Over here the shrinkage, sorry, this is linear. Okay, so this is WS and plastic limit, liquid limit. So in that, on the basis of that only it gets solved. So try to solve this. If not, I will cover it in the subsequent classes. Okay, this thing is also discussed in the previous class. Over there, we discussed the consistency. Okay, liquid limit and consistency limit are two terms. I will write the equation for that. Okay, so um, uh, consistency limit. I see. This is WL WL minus WN. So Wn is the water in the natural content. This is nothing but IP. So WL minus Wn by IP is IC, while consistency index and liquidity index is given as Wn minus Wp divided by WL minus Wp. You can also write it as Wn minus Wp upon IP. IP is the plasticity index. This is the liquidity index. Similar in a similar manner, you can also write it as well as WL minus WN upon the liquid limit minus plastic limit is nothing but IP, plasticity index. Right. So in the same fashion, the consistency, liquidity both each defined. Now you see that for the consistency, it is liquid if its value lie in the less than one. Conversely, for greater than one, for the liquidity index, for the consistency 0 to 0.25, it is very soft. For 0.25 to 0.5, it is soft, while for 0.5 to 0.75, it is medium stiff, and from 0.75 to 1, it is a stiff in nature. For considering for the semi-solid state, very stiff to hard greater than 1, and other hard and very hard it is mentioned, but in the same greater than one, it is hard, very hard. Now, we move to the seepage and permeability. So, we have talked about the flow takes place, but what is the rate at which flow takes place becomes also very much important as we move forward, because you know that we say that the soil is permeable, and how it is permeable, how the water is present, how water flow into the soil with the time, it's become equally important. Because if we say that soil is permeable, it allows the water to flow through them. Someone must be there who will ask that, okay, it will allow the water to flow through them, but how much time it will take to move, it will take to move the water from one point to the other. So you see that the permeability is defined as the property of soil that allow the seepage of fluid through them, and it's move through them through the interconnected void spaces. So Darcy defined a condition in which he say that uh, over here something is missing. I will try to it pen. He has explained as V equal to Ki. Right. So velocity is equal to Ki, and subsequently discharge is equal to Kia. Okay. So where K is the coefficient of permeability and V is the discharge velocity, eh, and I is the hydraulic gradient, that is delta H by L. Basically, this much delta H is the, okay, I will write it again, H K multiplied by delta H upon L multiplied by E. A is the area of cross section through which flow takes place. Delta H is the head loss takes between for the movement of distance L drop takes between point 1 and point 2. So where, and K is the coefficient of permeability, and V is the discharge velocity, I is the hydraulic gradient. And what is the hydraulic gradient? I have also explained over there. Now you see, I have given this example in the very first class only, in which I have said that if it is a very permeable soil like the gravel, it allows the water to flow through them very easily. Subsequently, in the granular soil also flow takes place more apparently, which is nothing but the gravel and sand only. But for the block soil, it takes place in this manner. But for the platy or maybe the clay or maybe the silt, the flow almost in the, those are very difficult to carry the flow through them, and that's why it's become very much important. Now, when we talk about the total head is the combination of elevation head plus pressure head plus velocity head. But in the soil mechanics, the velocity head is negligible. Hence, we neglect that term and we talk about only the elevation head and the pressure head only. And it is already written over here as well that the seepage velocity is very less. Hence, the velocity head can be neglected, and the head at A equal to Z into A plus H into A. Okay, there is a picture maybe there. Okay, something get missed out. That's why this content has been written is not explained over here. But let me see. Okay, no problem. And the hydraulic gradient I have already explained as delta H upon L. L is the length through which it moves takes place. Now you see over here a picture is given in which the water table in the upstream direction. Let me take a laser so that I will show you very easily. Okay, now you can see over here the water table is relatively up as compared to this cross section. Now, in general, the water takes flow takes place from the high head to lower head. So, in this case, also the similar condition gets arrived. Now, the distance L, this is the distance L through which the flow takes place, and this is the H, the head which is lost during the movement of water from this place to this place through the soil mass. So, this H upon L is the hydraulic gradient, and this H is the head difference between these 2 points. So the hydraulic gradient is nothing but H, this H upon the L value. Right. Now you can see that when we are going to calculate the permeability, we see that how much time it will take from the movement from point A to point B, and the time taken by that is given by in the L by T, that is equal to V, that is equal to Ki, and I is already know, so the K value get calculated. Right. Now, okay. Now, you can now we have some empirical and some other relation through which we calculate the permeability of soil. So the one of such relation is given by Hagen 1892, who started this for the clean sand. There he explained K as 100 D10 square, mm, that is in the mm per second, but in this case it is an empirical relation. The D10 value must be in mm. Okay, sorry. Okay, so now here you see that the permeability value for the different type of soil is given. The table is a little bit tilted. The permeability for the gravel is greater than 10 to the power minus 1 meter per second, while for the sand it's lying in the range of 10 to the power minus 1 to 10 to the power minus 5. And subsequently for the sand it's lying in the range of 10 to the power minus 5 to 10 to the power minus 7 meter per second, while for the fine coarse silt clay, it goes on decreasing as we move ahead. Okay. Now we move to the factors that affect the permeability of soil. So there must be some factor which influences the permeability. Hence, let me see. Okay. Okay, so now we are going to move to the factor that influences the permeability of soil. So some of those factors are the shape and size of soil particles. Another one is the void ratio. Then the permeability increases with the increase in the void ratio. If the void ratio is no more, if the volume of void is more. If the volume of void is more, the flow of water takes place through void is more. Hence, the permeability get increased. But the another question also get asked, at how the permeability of soil get reduced. So if there is a high effective pressure, high compaction also takes place, the permeability get affected. So the other thing which influences the permeability is the degree of saturation. Permeability increases with increase the degree of saturation, and subsequently talking about the composition of soil particles. For sand and silt, this is not important. However, for the soil and clay minerals, this is Sorry. One of the most important factors, the permeability in this case depend on the thickness of the water held to the soil particles, which is a function of cation exchange capacity, valence on the cations, etc. Other factors remaining the same, the coefficient of permeability decreases with increasing the thickness of the diffuse double layer. Okay. Now, moving further to some other factors like the soil structure. The fine grained soil with the flocculated structure have a higher coefficient of permeability than those with the dispersed structure. With increase of the moisture content, the soil becomes more and more dispersed. With increase in the degree of dispersion, the permeability decreases. The viscosity of the permanent, basically the material, the water, the particle content which flow through soil, their viscosity become also very much important on the on the permeability. Other thing is the density and the concentration of the fluid substance which move through soil, which also play its relevance in affecting the permeability. Now, now we talk about the determination of permeability. Now we talk about the determination of permeability of soil. So how we calculate the permeability of soil? So there must be some lab method, there might be some field method. So talking about the laboratory method, the first one is falling head method. This is very much good for the fine grained soil. Well, other is a constant head method, good for the coarse grained soil. So constant head method is nothing but that is the Darcy law itself. In a constant head method, the equation which is used to calculate the discharge or K is nothing but Q equal to KIA, where K is the coefficient of permeability that need to be calculated, and how it is achieved by the in a constant flow, in the constant head method I am talking about. I the hydraulic gradient and delta H by L which we discussed earlier. But for the falling head, for the falling head, it become Q equal to K H. um, falling head method, I think so I have written something different. Let me erase this. In a falling head method, it become okay. For the falling head method, we will write Q K equal to 2.303 AL upon 80 log H1 by H2. So this is the relation which is used to calculate the permeability in the falling head test, where 2.303 air by 80, where A is the area of that thing. Okay, we will see once it comes. The constant head method is good for coarse grain soil, while the falling head method is good for the fine grain soil. Now talking about the field method, the field method, one is the pumping in test, and second one is the pumping out test, third one is the packer test, and fourth is the borehole test. While the some of the figures is also presented to show the same. Over here, Q equal to KIA, where I delta H by L is mentioned over here, which we have discussed earlier as well. Subsequently, from the Darcy law, Q equal to KIA, hence the quantity of flow Q equal to Q upon T, where I is the hydraulic gradient, H by L, where I is the hydraulic gradient, which is also written as H by L. A is the cross section area of the sample. Q is the total quantity of water flow over the time T. Hence, K can be obtained over here as Q by Ki. I already mentioned Q equal to Kia is used to calculate the K value, which has been used over here. Now move to the falling head test. This is the thing. So during this test, the water is in the stand pipe fall from height h1 to the final height h2. The let the h be the height at some point, sometime t. Considering the small interval dt, the net change in the level of h during this time be dh. That is negative h, that it drop into the elevation. The quantity of the flow through the sample at the time dt is equal to minus ADH and is given by symbol dq. Similarly, when we solve it out, we are able to find as k equal to AL by AT ln h1 by h2, which I have written earlier as k equal to 2.303 AL upon AT log h1 by h2. In this regard, A is the cross-section area of the sample, small a is the cross-section area of the standing pipe, is the length of the sample, the time over which the head dropped from H1 to H2 is the time T. Right. Now, now we see the field permeability test, the pumping test. So we are talking about the unconfined and confined aquifer. Now, there is a difference between the unconfined and confined aquifer. When we talk about the unconfined aquifer, we talk about the layer, the upper layer from which the water has been excavated. While in the confined aquifer, the water table is get trapped between the two impermeable layer from which the water is get excavated. The relation to calculate the permeability for the unconfined and confined aquifer is also mentioned over here. For the unconfined aquifer, permeability is given as K equal to 2.303 Q log 1 log R1 by R2 by upon R1 by R0, we can also say upon 2 pi upon pi h2 square upon minus h1 square. That is mentioned over here. The small point is also mentioned that consider an intermediate distance r from the center line of the pumping well and let the height of groundwater table above the sorry impermeable layer during the pumping B. The hydraulic gradient I is equal to the slope of the HR curve, that is the delta H by R, delta R, and area of the imaginary wall of the cylinder of radius R and height H. So when we write the equation and derive, we are able to find K equal to Q into log R2 by R1 by pi H2 square minus H1 square for the unconfined aquifer. So subsequently, the according to Kojni, the maximum radius of influence R is drawn due to pumping is given by these equations, where the N is the porosity, R is the radius, and T is the time during which the discharge of water from the well has been established. And the relation in the term of R and R naught could be rewritten as Q into ln R upon R naught by pi H square minus H naught square. And the depth H at any distance R from the well, RW to R can be determined from the previous equations derived by substituting H1 equal to H naught at R1 equal to RW and H2 equal to H at R2 equal to R. Now K could be written for over here as Q into ln R upon RW, because here the two distance has been established. So pi divided by pi into h square minus h naught square. Similarly, by solving here to there, the h value could be calculated from the following equation which he mentioned in the this slide. Now, we talk about the confined aquifer. As we have already said, the confined aquifer is that layer in which the water is trapped between the two of the impermeable layer, which need to be brought out for the use of for the different purpose. So the permeability must be there over as well. Again, when we derive over here, the equation comes to be Q into ln R2 upon R1 by 2 pi h into 2 pi h into h2 minus h1, where h is the thickness of the aquifer, confined aquifer layer. Subsequently, it is important to note that a sedimentary deposit may consist of the several different soils, and it is often necessary to determine the average values of permeability in two directions, one parallel to the bedding planes and other at the right angle to them. Let H be the n layer of thickness H1 H2. Okay, now we are going to calculate the permeability in the parallel for the parallel layer and for the perpendicular layer. So the thickness of each layer has been given as H1 H2 H3 and Hn, and the total thickness of layer be H. So let Kx1, Kx2, Kx3 and Kxn be the representative of the coefficient of permeability parallel to the bedding plane, and Kxc be the average permeability parallel to the bedding plane. Hence, considering the flow parallel to the bedding plane, Q is written as A into Kx into I, where A is the total area and I is the hydraulic gradient. Right. Now, the total flow must be equal to the sum of the flow through each layer. Therefore, it is mentioned that Kxe is nothing but summation of Kh divided by summation of H. Since it is the flow of water takes place parallel to the flow direction, and flow takes in the perpendicular direction, this equation get converted as summation of H upon summation of Hi by Ki, which is also mentioned over here, that considering the perpendicular to the plane and considering kz1, kz2, kz3 and kz1 representing the permeability perpendicular to the bedding plane in the respective layer, the total flow Q is given as akz1 I1 equal to akz2 I2, because discharge remains constant when we flow in the perpendicular direction. So H1, H2, H3 are the head losses. So KZI, KZS is written as H1 plus H2 plus H3 plus dot 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 Hn upon H. Subsequently, the final equation gets comes like this, that KZE, that is in the perpendicular direction, H upon H already said, summation of Hn by Kn. With this, the today's session gets concluded. Now we move to the small questions and some of the session within the 5 to 10 minutes. Right. So this is the small problem asking that what are the three phase represented in the soil mass? Options are air, rock, vegetation, wrong. Air, water, solid, right. Water, clay, sand, wrong. Sand, silt, gravel, wrong. So option B is a correct answer. Next question say that in the three-phase diagram, what does the void sections consist of? So in the three-phase system, void consists of either water or air. So only water wrong, only air wrong, water and air right, only solid wrong. So option C is the correct answer. Okay, here over C. Now next problem say which of the following statement is true for fully saturated soil? Option A say that the void are filled with the only air, wrong. Voids are filled with only water, right. Voids are partially filled with water, partially saturated हो जाएगा, no. And the no water exists in the sample, so the option B is the correct answer. Next is what is the symbol most commonly used for the void ratio? So E is used for the void ratio. Over here, N is used for the porosity. S is the used for degree of saturation. W is used for the water content. Here, void ratio is asked. So option number B is the correct answer. Right. Now, next is which property describes the ease with which the water passes through the soil. So the plasticity, no. Permeability, right. Compressibility, no. Liquid limit, no. So the option B is the correct answer, right. Next question asks the coefficient of permeability of often measured in, okay. So coefficient of permeability K is measured in the meter per second, as I remember. So option B is the correct answer. Yes. Next is the unit weight of water is closest to 10 kilonewton per meter cube, 9.81 kilonewton per meter cube. So I think so. What will be the answer? Option number B. Sorry, C. Unit weight. It is asked about unit weight, density of water, not. So option C. Next is which test is commonly used to determine the permeability of coarse grain soil? It is already said that for the coarse grain soil, the constant head test, falling head test for the fine grain soil. So option number A is the correct answer. And then the next question is the property that measures soil ability to allow the passage of fluid is called porosity. Nahi, strength, no. Permeability, yes. Compressibility, no. So option number C is the correct answer. Next, in the Darcy law, the flow rate is directly proportional to. So V is what is the V equal to K? You know now V. Sorry, option already come. So the permeability and hydraulic gradient. Why? Because V is equal to Ki. So it is directly proportional to permeability as well as hydraulic gradient I. Right. Next question say Darcy law ceases to be valid when the soil is dry, flow is turbulent, flow is laminar, soil is coarse. So option number B, soil flow is turbulent. Let's say that if the soil has a permeability of this, it is considered to be. So I think so. I have written the permeability range as well for the different soil characteristics. If you remember this, you can easily answer this. That the option number C is the correct answer for this problem. Next is the effective stress in the soil is calculated as effective stress is the total stress minus pore water pressure. As I recall, we have not read it today, so if you are not able to answer this, that's not the problem. The effective stress of soil is calculated as total stress minus pore water pressure. So option A is the correct answer. When the degree of saturation is 0, the soil void are filled with. Okay. Degree of saturation is 0, hence volume of water is 0, so it is filled with air only. Option number B is the correct answer. Next is the term seepage in the soils refer to air movement, flow through soils, soil compaction, soil plant interaction, so water flow through soils. Bombay. B. With this, uh, we come to the end of the today's session, and I think okay. I think so. I think so. With this, the time is also get over for today. So now I'm going to close the today's session. Some important points before ending this today's session is that this entire session is recorded and will be uploaded on the YouTube by today only, and the link will be shared with you by the NPTEL team. The content which we have discussed over here will also be shared with you in the form of PDF by this evening. So I request you to kindly solve some problems related to the today discussion so that you are able to develop the better understanding of the subjects. With this, I sum up the today's session. Thank you everyone for attending. See you in the next class. Thank you very much.